Okay, so right now we will focus mostly on the guidelines for installing SPHINX and on the user perspective. We talked about the DTM, the VAS, and I presented some features of and the figures how the components are interacting each other, but we will go on specific details about the deployment options and what are the best practices on deploying SPHINX. And so this is mostly focused on end users and not very, experienced users. So I will go step by step, defining that normally until nowadays we used to software as a service, meaning that we most probably execute a software inside Windows machines or Linux machines. We get some processes, some functionalities, we execute, and then we get reports back. That was the normal process a lot of years back now. But right now the services actually are going beyond that perspective, moving on the cloud services and moreover on microservices more specifically. So the microservices, like I explained from the CM side, but other components also use microservices, meaning that they hold an Elasticsearch as a database, which runs as a different service, and there are other services like API interfaces, and all of them comes together. So this is a novel way to go beyond the traditional efforts. The microservices as an approach, of course, it increases some of the complexity, meaning that you have to interact between the microservices, but it provides flexibility, it's resilient, you can update more frequently, you can handle downtimes. There are multiple benefits on having microservices. I will not explain all the benefits, the literature, and all the information on the internet can provide you about what are the benefits of microservices. Normally, most of the tools right now, open source tools as well, use Elasticsearch or the Elk stack as well, meaning that they hold a dashboard like Kibana, an Elasticsearch for saving the data, and for the data parsers to have like beats and data shipping by using Logstas and so on. Similarly, we use the same approach on the CM that I presented before, and some of the other components use Elasticsearch as well. There are some differences. For example, the SPHINX Toolkit uses as a central dashboard the interactive dashboards, which is based on Grafana instead of Kibana, for example. So there are multiple ways of interacting, and it's flexible to have a dashboard by using Grafana while you have the Elasticsearch to save the data. Regarding the Logstas and the data shipping, some tools like the DTM use Logstas. In our case, on the CM side, for example, we use our own developed agent to parse data. So yeah. Are there any questions? Sorry, I can hear some background noise. Okay, sorry for that. So this, it's a common architecture that we use also on the SPHINX architecture. That's why I presented. It's a very popular approach of the Elk stack. So that's why I presented. The topology, the SPHINX deployment, it's like we have right now on DP5. It's a cluster of hospitals in Greece. There are deployed options like Windows Server, and inside DP5 there are other databases and systems and services that the hospitals normally use, meaning a web application to store patients, to conduct lab tests and save the medical records. So all of them are deployed on DP5 as a replicated environment for us to execute use cases, attack scenarios, and have the security controls deployed by the SPHINX toolkits to interact with the attack scenarios. The CM, the DTM, the VAS are stored internally on DP5. The VAS conducts investigations of vulnerabilities of these systems. The DTM captures the network traffic inside DP5 and reports. The CM also runs internally in order to interact directly, while we maintain some services outside of DP5, like the Kafka server, for example, where the alerts or the log files are stored, and other components from the SPHINX toolkit. Meaning that we want to, to have a lighter version on DP5 and have some of the workload on Intracom's side on the server. Both of them here, for example, the DTM actually, and the VAS, and some of the components here are deployed on Kubernetes cluster. And yeah, the Kubernetes cluster I think that nowadays most of the people know about Kubernetes. So it's a cluster of components that can handle actually services in a very comfortable way. The best practices that we discovered from the deployment of DP5, and we also intend to help HESE in Evora, in Hospital of Evora, to improve and have the test environment for executing the SPHINX toolkits, included an SSD disks, which was an important feature. Every time you go on a virtualized environments, the hard disks fail badly. So the SSDs are very important in order to have a modern system that will handle these tools. Of course, I know SSDs are expensive most of the times, but it's something that it's very important when you enable security controls. RAM size is dependent on the environment, meaning if you have a lot of network traffic and you store all the traffic, then you will need a lot of SSD and also RAM in order to parse the data. So if there is a very large workload of network traffic or log files, then you will actually use a lot of RAM. Also, if you use a lot of components that use Elasticsearch, then you will also need a lot of RAM. So these are pretty resourceful tools, but it's the scalability is flexible. If it's a very small infrastructure, then you can have a very small server to execute the services. If the infrastructure is large, then higher amounts of performance is required, and also is regarding of what exactly you monitor, as I said. So that's about the scalability. And the Kubernetes is for continuous integration, meaning that you constantly want to update the code, do regular coding, experiments in order to improve the coding. Since we are talking about security, it's very important to keep the services updated. Other best practices include Docker, for example. If you don't want to use Kubernetes and to go on a very complex cluster of services, you can deploy individually the components by using Docker services. Although the Kafka, the Kubernetes node is proposed. The Kafka server is to be deployed as a main feature, to interact between the components. So that's important to have a stabilized version of a Kafka server. And for conducting experiments, attack simulations, and so on, it's important to select one of the hypervisors that are on the market, even if it's open source or commercial, like VMware, Proxmox, or go beyond, for example, by using Terraform. We did not go on that way on the SPHINX project, but it's something that it's very important to mention, that Terraform is a very novel way of virtualization option. Interactive dashboards are important for the end user. It's a bit on the final version of the project, but it's still very important for the end user to have dashboards that can understand. So the endpoint, the main endpoint is the interactive dashboards, and we have to focus on providing useful information to the end user, while the end user can always go inside the services and search more things, but having a dashboard that explains everything is the best. Okay, anything else like that? So DTM accordingly, okay, nothing else here. There are the installation steps, very fast. Select hypervisor technology, deploy the Kubernetes and the workers, deploy the Kafka server, deploy the services, and then deploy some other services that might require VM. For example, the FDC is about the forensics data collection engine, or the attack simulations might require external VMs that have to be deployed inside the system. Configure the services to interact with the Kafka topics. Configure what we want to monitor, meaning what kind of log files we extract. Then we execute the test scenarios, the attack scenarios. We iteratively check and configure the rules and extract reports and alerts according to the attack scenarios. That way, we can, we can guarantee that the security controls are enabled, and we can respond to cyber attacks. This is done on a test environment, but it's a very good approach in order to get familiar and enable it on the production environment as well. Okay, this is about the Kubernetes deployment. I will not explain. It's commands that easily can be performed in order to deploy a Kubernetes. Okay, there are some benefits. So some benefits is that you get familiar with the novel tools. Most of the people that are not on cybersecurity have not ever seen an intrusion detection system, have not ever seen a CM. So it's like many concepts that are on theory, they have the opportunity to get them as hands-on labs and try to interact and get familiar with these concepts. The test of the existing environment is important because hospitals can test actually the environment. They can check about what kind of vulnerabilities they have without exposing any critical information or have downtimes. So it's important to have a replicated environment and test the actual environment. Educate IT staff, not only on security, but in automated tasks that are very useful, like what kind of passwords they use. So it's like you increase security awareness when you proceed on such aspects. Going on the fourth step. And 5, improve the infrastructure. So it's like you revise and check up things. So you are thinking about what kind of backup plans are there. You identify attack vectors and the attack surface that you did not know before. So you improve the infrastructure overall. This increases also situational awareness, since you are actually revising and understand your overall infrastructure. So it's better afterwards to understand what's happening inside the infrastructure. And overall, you define better security controls to be followed. So like identity management controls, authentication schemes. So you improve the protocols because you are able to identify any flows, security and configuration flows. So you are actually going to improve the security protocols that are be followed inside the organization. So that's it about the deployment options and how to deploy SPHINX, and some details about the novelty and the benefits of the approach. Thank you very much.